So, hello, a very good evening to all, and welcome to the class. So, I hope my voice is audible to all of you. Just give me a confirmation. My screen is visible to all of you. Screen visibility and voice के लिए एक बार confirmation दे दो. Then we are going to start the class today. Okay. Okay. So, in today class, basically we are going to start D and F block element crash course, right? So, in the previous class, we already covered chemical bonding. So, in today class, we are going to see D and F block elements. So, in starting 22 or 25 minutes, we are going to see the main concept of these chapters, DNF block elements, right? And after the concept, we are going to solve some PYQ questions based on this chapter only. Okay, so this is totally today plan for DNF block elements. चलो so start करते हैं फटाफट. So if we consider the D block elements, look at the periodic table, right? So if we consider the periodic table, then you can easily find the position of D block element. So the first two groups are called S block element, and the middle one between S and P block elements are called D block elements, and just below the D block we have F block elements. So basically in D block, how many groups we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have total 10 groups. So total 10 groups in D block. And how many periods we have? That is 1, 2, 3, 4. So total we have a 4 period, right? 3D series called 4D series, 5D series, and 6D series. In 5D and 6D series, actinoids and lanthanoids are also there. That is F block elements. Okay, so this is the position of D block elements in the periodic table. So I hope this is clear. So the 3D series start from scandium to zinc, 4D series from Y to CD, 5D series from La to HF, and 6D series from Ac to RF, right? Now, if we consider the general electronic configuration of D block elements, so what the electronic configuration? The general electronic configuration is n minus 1, D 1 to 10, n is 1, 0 to 2. For example, in 3D series, we use 3, n is equal to 3. In case of, in case of 3D series, we are using, what is n here, beta? Can anyone define? So n is nothing but 4, right? So 4 minus 1, that is 3D1, 3D4. Similarly, in this series, next series, we can use n is equal to 5 and n is equal to 6 and so on. Okay, so these are the electronic configurations of 3D series only. Done. Now here, two exceptions are there in case of electronic configuration. That is chromium having electronic configuration 3D4. 3D4. So how will you write it? So we can write 3D4 as 3D5 4S1, right? Because 3D5 is half filled electronic configuration. Similarly, copper having 3D9 configuration originally. So we can write as 3D10 and 4S1 for the copper. Done? So, let's see some important properties if we talk about. So, whenever you move from left to right in the periodic table, the effective nuclear charge increases, right? So, whenever you move from left to right, right, left to right in the periodic table, effective nuclear charge increases. What increases, beta? Effective nuclear charge. So, we can say that as the effective nuclear charge increases, ionization enthalpy also increases. Okay, so whenever you move from scandium to zinc, or you move from that is Y to cadmium, or lanthanum to mercury, we can say that their nuclear charge increases. As a result, ionization enthalpy also increases. Now, if we talk about the first ionization, second and third, we all know what is first, second, and third. So if we know the order that which ionization enthalpy is more, then obviously third ionization enthalpy is the more. Then comes second and lowest for the first. So amount of energy required to remove electron, that is the third electron, is very much difficult as compared to second and first electron. And we know all this thing, right? Good. Now, what are the factors which affecting the ionization energy? So the attraction of electron towards the nucleus, the first thing, repulsion between electrons and exchange of energy. So these all are the factors which affect the ionization energy. Done. For example, if someone says out of chromium plus and manganese plus, which will show more ionization enthalpy. So let's consider their electronic configuration. If we consider the electronic configuration of chromium plus, it show that is 3d5 4s0, right? Now, if you consider the electronic configuration of Mn plus, so the electronic configuration of Mn plus is 3d5 and 4s2. So in chromium, they are stable electronic configuration. Why? Because they are half filled. But in case of manganese, they are not half filled. They are having 3d5 and 4s2 electronic configuration. So they are stable. In which case, beta? So they are stable in plus 2 case, because in plus 2 case, Mn having 3d5 electronic configuration and chromium having 3d4 electronic configuration only. So we can say that in plus 2, Mn show more ionization enthalpy, but in plus 1, chromium show more ionization enthalpy compared to manganese. So this thing you need to remember and you need to write before you predict the ionization enthalpy कि कौन ज्यादा शो कर रहा है कौन कम शो कर रहा है. Done? Chalo. Now, the oxidation state, it's also very, very, very important topic, right? So, in oxidation state, just remember three things, that is D0, D5 and D10, right? Everyone wants to become like this. यानी जितने भी element है 3D series में या 4D या 5D में, everyone wants to gain such kind of stability, either half filled, fully filled, or zero configuration. Now, if someone asks out of this D5, D0, and D10, which is the more stable? So obviously D10, D5, and then comes D0. So if someone asks out of titanium 4 plus and titanium 3 plus, which one is more stable? So we can say that titanium plus 4 is much more stable because they're having 3d0 electronic configuration. Similarly, if someone asks out of Mn2 plus and Mn plus 4, which one is more stable? So Mn2 plus having 3d5 electronic configuration, where Mn4 plus having 3d3 electronic configuration. So we can easily say that Mn plus 2 being half filled, being 3d5 are much more stable as compared to the other. Clear hai? Chalo. Now, basically, if you consider the periodic table, so the representative element like S block and P block, they show oxidation state according to their group. For example, group 1 show plus 1 oxidation state, group 2 show plus 2 oxidation state, and so on. Similar for the others group, right? Like group 15, 16, 17, and 18. But what about the D block? So these D block elements show all different kind of oxidation state, right? Let's see. So the most important thing is, as the oxidation state increases, ionic character decreases and acidic character also increases. So this point you need to remember, right? Ki as the oxidation state increases, ionic character decreases and acidic character increases as well. Now, अब देखो मेरे पास कौन कौन से कंपाउंड है. सो वी हैव एन अ कंपाउंड लाइक MnO, MnO2, and the next is Mn2O7, right? So we have a different forms of compound like MnO, MnO2, and Mn2O7. Now, if we talk about the character, then MnO show ionic character, MnO2 show ionic and covalent character, and Mn2O7 show covalent character. Their oxidation state, देखो ध्यान से. So MnO show plus 2 oxidation state, MnO2 show plus 4 oxidation state, and Mn2O7 show plus 7 oxidation state. ठीक है. Now, अब एसिडिक नेचर की बात कर लो अगर. सो प्लस 2 ऑक्सीडेशन स्टेट मींस दे आर बेसिक, plus 4 means amphoteric, and plus 7 means acidic. So the simple relation between the acidic character and oxidation state is that as the oxidation state increases, acidic character also increases and ionic character decreases. ओके, सो जो सबसे ज्यादा ऑक्सीडेशन स्टेट है मैंगनीज का, दैट इज +7. सो दे आर कोवलेंट इन नेचर, नॉट आयोनिक, राइट? सो एज द oxidation state increase, ionic character decrease, and acidic character increases. Done? Okay. Now let's see the important thing. The most stable oxidation state, that is the most stable oxidation state is +6 of MOW in case of MO3 and WO3. And due to this, they act as a very good oxidizing agent, right? Now, let's see the stability of higher oxidation state in 3D series. तो अगर मैं higher oxidation state की बात करूं, in case of oxides and fluorides, so oxides are much more stable as compared to fluoride. For example, Mn2O7 exists, MnF7 cannot exist. Only Mn4 exists, right? MnF4 exists. So why this is? So basically the stability of in higher oxidation state, ऑक्साइड जो होते हैं उनकी स्टेबिलिटी ज्यादा होती है. ऑलवेज रिमेंबर, क्यों? क्योंकि डबल बॉन्ड बनाएगा, ऑक्सीजन है जो, ऑक्सीजन क्या बनाएगा? डबल बॉन्ड बना रहा है, तो 2 to 4 to 6 6 7. जबकि ये सिंगल सिंगल बॉन्ड बना रहे हैं, तो साथ साथ इसके आसपास नहीं आ सकते हैं, वो वहां पे बहुत ही ज्यादा बल्कि ग्रुप हो जाएगा, ज्यादा ग्रुप्स हो जाएंगे, स्टेरिक इफेक्ट आ जाएगा पिक्चर में, राइट? सो ये याद रखना है. नाउ इफ यू टॉक अबाउट द मैग्नेटिक प्रॉपर्टी, देन दे मैग्नेटिक प्रॉपर्टीज आर diamagnetic, paramagnetic, and ferromagnetic. So basically these are three main magnetic property in which we classify the different elements कि कौन कैसा बिहेव कर रहा है. ओके, नाउ अगर आप देखो टाइटेनियम को, वैनेडियम, क्रोमियम, मैंगनीज, सो टाइटेनियम वॉयलेट कलर का होता है, वैनेडियम वॉयलेट ग्रीन एंड दिस. उसी तरीके से क्रोमियम भी कलरफुल कंपाउंड बना रहा है, राइट? अगर मैं मैंगनीज की बात करूं, दे ऑल्सो फॉर्म कलरफुल कंपाउंड पिंक कलर का. आयरन ऑल्सो फॉर्म कलरफुल कंपाउंड, कोबाल्ट ऑल्सो फॉर्म निकल एंड कॉपर. सो color ions, why they are colored? If someone asks why d block elements are colorful in nature, why they form colorful compound, so answer is due to dd transition. Which transition beta? Due to dd transition takes place due to presence of unpaired electrons. So due to presence of unpaired electrons only they are colored in nature. किस तरीके से होता है dd ट्रांजिशन? सो दिस इज द लोअर एनर्जी डी ऑर्बिटल एंड दिस इज द हायर एनर्जी डी ऑर्बिटल. सो यहां से इलेक्ट्रॉन का क्या होता है? ट्रांसफर होता है लोअर टू हायर, एंड व्हेन दे रिटर्न बैक फ्रॉम हायर टू लोअर दे एमिट एनर्जी, दे एमिट रेडिएशन, जिसके चलते वो अलग अलग कलरफुल कंपाउंड दिखाई देते हैं. इज दिस क्लियर टू एवरीवन यहां तक? कोई भी डाउट हो किसी को भी पूछो एक बार. एनीवन हैविंग एनी काइंड ऑफ डाउट टिल? यस, यू कैन आस्क. एनी डाउट टिल? नो? ओके. Now, what about V5, Cr plus 6 and Mf7? They are they doesn't contain any unpaired electron. Then how can we say that they also form colored ion, right? They are also make colorful compound. How is that possible? So you have to say in this charge transfer takes place. So in V+5, chromium, vanadium, chromium, and manganese, right? So V+5, chromium +6, and Mn+7, no unpaired electron. However, they form colored ion due to charge transfer. So remember this term as well. Now, they also form complex compounds. So formation of complex compound also took place. So various complex compound जितने भी होते हैं वो सभी डी ब्लॉक एलिमेंट्स के होते हैं. So इनके पास स्ट्रॉन्ग टेंडेंसी होती है कॉम्प्लेक्स बनाने की. Why they have a strong tendency to form complex? Due to a smaller size, high ionic charge, and availability of d electrons. So due to this three reason only, they have a strong tendency to form complex compound like FeCN6 3 negative you can see, FeCN6 4 negative you can see. These all are the ionic compounds. Now let's see the classification of alloy first. So alloy are classified into the two types. ferrous alloy and non-ferrous alloy. Ferrous alloy means they contain iron, right? And apart from iron, they contain certain metal or non-metal as well. But the main constituents is iron. And the non-ferrous alloy, they don't contain iron, like brass and bronze. Okay. So when the iron contain is less than 0.1%, they are called iron alloy, or higher than 0.1%, then they are called steel alloy. So remember this thing. Okay. Now, let's see the important compound K2Cr2O7. So this K2Cr2O7, they are interconvertible in aqueous solution. Depends upon the pH value. Matlab, Cr2O7 or CrO4, they are interconvertible to each other. Okay, depends upon the pH. Now, what is the structure of this chromate and dichromate? If someone asks what is the structure of the chromate and dichromate, how will you actually draw the diagram? So this is the structure for CrO4 twice negative. किसके लिए है ये? CrO4 twice negative, and their structure is tetrahedral. Similarly, this is structure for Cr2O7 twice negative. This also showing tetrahedral structure. Now, in acidic solution, this potassium dichromate, that is K2Cr2O7, furnishes nascent oxygen. And that is the reason why K2Cr2O7 is a very, very good oxidizing agent. Why? Because they provide nascent oxygen for the oxidation to take place, right? So if someone asks, क्या आप मुझे बताओ कि whether there is a good whether they are the good oxidizing agent or not. So you can say yes, K2Cr2O7, KMnO4 both are good oxidizing agent. Why? Because they produces nascent oxygen. और जो भी nascent oxygen produce कर रहा है वो अच्छा oxidizing agent है, because वो help कर रहा है oxidation कराने में, right? So Cr2O7, they converted into 2Cr plus 3. So we can say that there the oxidation number is 6 and they reduces to 3. So we can say that they are very good oxidizing agent, right? So जिसका भी reduction होता है, they act as a very good oxidizing agent. So ये alcohol को oxidize कर देते हैं acetic acid में, ferrous sulfate को ferric sulfate में. So they oxidize all this thing. Okay. हाइड्रोजन सल्फाइड को सल्फर में कर देंगे, हाइड्रोजन क्लोराइड को they converted into chromium chloride. So these all are act as a very good oxidizing agent. Is this clear to everyone? ये क्विक रिकैप था डी ब्लॉक एलिमेंट्स के बारे में. एनीवन, किसी को कोई भी डाउट हो तो एक बार पूछो अभी तक. एनी काइंड ऑफ एनी काइंड ऑफ डाउट टिल एनी काइंड ऑफ डाउट यू कैन आस्क. देन वी मूव टू द एफ ब्लॉक एलिमेंट. फटाफट, किसी को कोई भी डाउट हो तो पूछ लो. हैव 1 मिनट, तुम पूछ सकते हो. यस. नो. चलो, then we are going to see the F block element as well. Now, what are the learning objectives? So in this, we are going to study about the lanthanoids and actinoids. These two group only. So these two groups play a very important role, lanthanides and actinoids. So let's understand these two groups. So where is the position of F block? So F block just lie below the D block elements in the periodic table. Now, it consists of two groups only. The first group is called lanthanides because it start after the D block element lanthanum, right? So ये lanthanum के बाद start होता है D block elements में. That's why they are called lanthanoids. And the next one is actinoids. So let's study lanthanoid first. So the most common oxidation state of lanthanoids is plus 3. So plus 3 oxidation state is the common oxidation state of the lanthanoid. All elements show plus 3 oxidation state. However, if you consider Ce, which having atomic number 58, they also show plus 4 oxidation state, right? They also show plus 4 oxidation state and act as a very, very strong oxidant. Okay. Now, if you consider Pr, Nd, Tb and Dy, right? So their oxides are PrO2, NdO2, TbO2 and DyO2. Okay. Now, so what are the physical characteristics? So they all are silvery white soft metals. They tarnish rapidly in air. हार्डनेस इंक्रीज विद द एटॉमिक नंबर, मतलब जैसे जैसे एटॉमिक नंबर बढ़ेगा वैसे वैसे हार्डनेस भी बढ़ेगा. दे आर अ वेरी वेरी गुड कंडक्टर ऑफ हीट एंड इलेक्ट्रिसिटी. Now, lanthanoid ions show color in both solid state and aqueous solution, right? And all lanthanoids are paramagnetic apart from these few, right? यानी सभी के सभी लैंथेनॉइड्स पैरामैग्नेटिक होते हैं एक्स La3+, C4+, Yb2+, and Lu3+, right? So apart from these four, all lanthanoids are paramagnetic in nature. Now, let's see. Let's see the chemical reactivity of lanthanoids. So, if you want to remember the reactivity of lanthanoids, just consider lanthanum in +3 oxidation state, right? So, +3 oxidation state की तरह इसको consider कर लो, तो सारा reactions आप easily बता सकते हो. When you react with halogen, they will form LNX3. Simple. When you react with H2O, they will form LNOH3. When they react with the heated with the carbon at 2773 Kelvin, they form LnC2. Similarly, when they heated with nitrogen, they'll form LNN. When they treated with sulfur, they form Ln2S3. Similarly, when they burn in O2, they form Ln2O3. Right? They form Ln2O3. So these all are the reactions of lanthanoids, right? तो ये सारा सारा हमारा क्या है रिएक्शन lanthanide का रिएक्शन है. Is this clear? Yes. Is this clear to everyone? Now, what about actinoids then? What are the actinoids? So in actinoids, we have 5F series, right? So actinide which belong to which series? It's belong to 5F series. So they are artificial process से भी बनाया जाता है इनको, naturally occurring भी होते हैं कुछ. ज्यादातर इसमें सभी रेडियो एक्टिव होते हैं apart from few. Okay. Now, next thing, they also are silvery in appearance, highly reactive, especially in finely divided form, paramagnetic होते हैं, and turnish in air due to oxide coating. Their reaction is almost similar, right? AnCl3, nitric acid के साथ no reaction. With H2O, they form AnH3, NaOH, no reaction. Heated with H2, AnH3, halogen के साथ AnX4, and with O2, they form An3O8, right? So let's see the main differences between lanthanoids and actinoids. So you can refer this table, right? Like if we talk about the oxidation state, lanthanide so +3 in most cases, +2 and +4 are also available. Actinide so wide range of oxidation state like 3, 4, 5, 6, 7, all the oxidation state. Binding energies, so binding energy of 4F are higher, 5F are lower. 4F electrons have a greater shielding effect and thus less contraction. 5F electron have a poor shielding effect and thus have a more contraction. Tendency to form complex is less, comparatively higher tendency to form complexes. Basic character, if you consider, lanthanoid are less basic, actinoids are relatively more basic. Only promethium is radioactive in the lanthanoid series, and in this all actinoids are radioactive. सभी के सभी radioactive होते हैं. Most of their ions are colorless, as the large number of ions are colored. That is, U is red color, U4 is a green in color, UO2 is in yellow in color. तो उसमें बहुत सारे colorful compound होते हैं. Now they are paramagnetic and their magnetic property can be identified easily, but they are also paramagnetic, but very difficult to identify their magnetic property. They do not form oxoanion, they form oxoanion like UO2 and BO2 and UO2+2, right? So these are the main differentiate between these three. Now let's see some previous year question. So the first question, ये 2024 का ही question है, 2024 का ही. What they asking बेटा? They are asking, tell me the electronic configuration of einsteinium, right? So their atomic number is given einsteinium. So einsteinium का atomic number is 99. What is the electronic configuration, right? So basically the correct option for the electronic configuration is 99, right? So the option C is absolutely correct. That is Rn, 5F 11, 6D 0 and 7S 2. So this is the correct one, right? Why beta? बिकॉज यहाँ पे सबसे पहले तो आर एन नोबल गैस का रिप्रेजेंटेशन हो गया. फिर हम वी नीड टू फॉलो द अबाउ प्रिंसिपल, राइट? सो व्हेन वी फॉलो ऑल दिस रूल यू गेट टू नो दैट इज ऑप्शन सी इज एब्सोल्युटली करेक्ट. नाउ टेल मी द नेक्स्ट क्वेश्चन व्हाट दे आर आस्किंग. The electronic configuration of copper 2 plus is 3d9, right? The electronic configuration of copper plus 2 is 3d9, whereas that of copper 1 is 3d10. Which of the following is correct? बोल रहा है इलेक्ट्रॉनिक कॉन्फ़िगरेशन कॉपर प्लस टू का करो तो 3d9 है, whereas that of copper 1 is 3d10. Which of the following is correct? B. Copper 2 is less stable. Okay. Anyone else? Why copper 2 is less stable? Remember this thing. Copper plus 2 is more stable, right? बिकॉज कॉपर टू में हम और भी बहुत सारे फैक्टर्स देखते हैं, सिर्फ आप ये नहीं देखेंगे 3d10. या दिस इज करेक्ट इफ यू कंसीडर D0 D5 D10 के हिसाब से देख रहे हो तो नहीं. बट इन एक्वस और भी अलग अलग फैक्टर्स आते हैं जिसको हम लोग देखते हैं, तो वी कैन से दैट कॉपर प्लस टू इज मच मोर स्टेबल. व्हाई? बिकॉज कॉपर प्लस टू में कन्वर्ट हो जाता है प्लस कॉपर में. इट शो disproportion reaction, right? Disproportion reaction. So we can say that the electronic configuration of copper 2 is this, where that of copper is which of the following is correct? Copper 2 is more stable, copper 2 is less stable. Stability of copper 1 and copper 2 depends upon the nature of copper salt. So the option A is correct. Copper 2 is more stable. Next, iron 3 catalyze the reaction between iodide and persulfate ions in which क्या करता है ये? Fe3 oxidize the iodide ion, Fe3 oxidize the persulfate ion, Fe plus 2 reduce the iodide ion, या Fe plus 2 reduce the persulfite ion. देखो, तो इट्स अ वेरी सिंपल रिएक्शन. क्या होता है इस रिएक्शन में अगर आप ध्यान से देखो, सो रिएक्शन इज लाइक दिस, that is this is Fe plus 2 and this is persulfite सल्फेट आयन S2 ट्वाइस नेगेटिव. तो इस रिएक्शन में क्या होता है? Fe कन्वर्टेड इनटू +3 एंड दिस विल कन्वर्टेड इनटू SO4 नेगेटिव. यानी Fe+3 ऑक्सीडाइज द आयोडाइड आयन, राइट? सो ये तो ये वाला हमने सल्फेट के लिए है ना, तो Fe+2 रिड्यूस दो पर सल्फेट आयन, राइट? तो ये इसको रिड्यूस कर रहा है Fe+2 क्योंकि खुद ही ऑक्सीडाइज हो गया है, तो इसको क्या कर दिया इसने? रिड्यूस कर दिया, राइट? सो इसने इसको रिड्यूस कर दिया, तो ये स्टेटमेंट तो बिल्कुल सही है. Fe+2 रिड्यूसेस द परसल्फाइट आयन एंड Fe+3 ऑक्सीडाइज द आयन. इसको देखते हैं एक बार ये क्या कर रहा है कि इफ वी हैव Fe+3 and when we treat with 2 iodine negative it converted into 2 Fe+2 plus I2, यानी जीरो -1 से जीरो कर दिया, मतलब ऑक्सीडाइज कर दिया. सो ए एंड डी बोथ ऑप्शंस आर करेक्ट. तो विच ऑफ द फॉलोइंग? C. So C option is absolutely correct. Done. Next, arrange the following element in the increasing order of number of unpaired electron. You want to try anyone? You just need to calculate the unpaired electron. मैं आपको वो भी लिख देता हूँ, सीरीज वाइज भी लिख के दे देता हूँ ताकि आप इजिली लिख सको. दिस इज स्कैंडियम, टाइटेनियम, वेनेडियम, क्रोमियम एंड मैंगनीज. This is 21, 22, 23, 24, 25. Now tell me, arrange the following element in the increasing order of their number of unpaired electron. You need to calculate the number of unpaired electron of all these four. निकालो एक बार. ए, ए बोल रहे हो, इट मींस ई में मैक्सिमम नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स हैं, देन बी, देन सी, और सबसे कम है स्कैंडियम में। यस, एनीवन एल्स? एनीवन एल्स जो कुछ और बोलना चाहता है? देखो भाई, सबसे पहले दिस इज ए, सो दिस इज 3D1, दिस इज 3D2, 3D3, दिस इज 3D5, एंड दिस इज 3D5। अब 4s की बारी है। 4s2, 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 4s1 and 4s2। आप देखो ना अनपेयर्ड इलेक्ट्रॉन। सो इन मैंगनीज वी हैव ओनली 5 अनपेयर्ड इलेक्ट्रॉन। इन क्रोमियम वी हैव 5 + 1, 6 in chromium. In vanadium we have only 3 unpaired electron. In titanium we have only 2. In scandium we have only 1. So correct order is not A beta. A गलत है। करेक्ट ऑर्डर सबसे ज्यादा बी है। बी, दैट इज क्रोमियम। तो क्रोमियम का सबसे ज्यादा है 6। देन कम्स 5, 5 पे कौन है? मैंगनीज। देन कम्स 3 वाला, 3 पे कौन है भाई? वेनेडियम। वेनेडियम के बाद टाइटेनियम, एंड देन आएगा स्कैंडियम। तो ये है ऑर्डर, दैट इज ए। ठीक है, ए के बाद क्या आ गया है? डी, टाइटेनियम। सो ऑप्शन बी इज करेक्ट। ठीक है, विच ऑप्शन इज करेक्ट? बी। इज दिस क्लियर? यस, समझ आया ये? यस, गुड। चलो भाई, नेक्स्ट। द नंबर ऑफ एलिमेंट फ्रॉम द फॉलोइंग दैट डू नॉट बिलोंग टू द लेंथेनॉइड्स। मुझे बताओ इसमें से कौन लेंथेनॉइड से बिलोंग नहीं कर रहा है? इट्स अ वेरी सिंपल वन। द नंबर ऑफ एलिमेंट्स फ्रॉम द फॉलोइंग दैट डू नॉट बिलोंग टू लेंथेनॉइड्स। कौन है जो बिलोंग नहीं कर रहा है, बताओ? बेटा सिंपल, ये सीएम, ये एक्टेनॉइड का है। राइट, तो जो सीएम है दैट इज क्यूरियम, ये एक्टेनॉइड सीरीज का है, ये लेंथेनॉइड में नहीं आता। तो आपको सीरीज थोड़ी याद कर लेना, एफ के जो है अपने लेंथेनॉइड और एक्टेनॉइड में। So they are asking the number of element from the following that do not belong to the lanthanoid. So answer is CM. ठीक है, डन, यहाँ तक क्लियर है? गुड। Now the next question. The number of ions from the following that have the ability to liberate hydrogen from a dilute acid. कौन लिबरेट कर सकता है, जल्दी से बताओ? Yes. How many number of ions basically that have ability to liberate hydrogen from the dilute acid? It's a simple question. हाइड्रोजन को अगर आपको डिस्प्लेस करना है, so obviously this question is belong to the reactivity series, right? If they are much more reactive than hydrogen, then only they able to displace hydrogen. Okay, now we all know that the electrode potential for hydrogen, right? H2 है ना, H2 2H plus कितना है? That is 0.00 volt. तो हाइड्रोजन का तो होता है भाई 0 वोल्ट, राइट। H प्लस से जब भी आप H2 में आते हो, रिडक्शन होता है, तो देयर वैल्यूज इज 0.00 वोल्ट. नाउ सो एनी मेटल आयन विद द नेगेटिव स्टैंडर्ड रिडक्शन पोटेंशियल compared to hydrogen has the ability to liberate hydrogen gas from the dilute acid, right? Because they are more likely to donate electron to H plus unfound in acid. So अगर आप वैल्यूज देखो, तो अगर मैं बोलूं वी हैव अ टाइटेनियम प्लस टू टाइटेनियम, दे ऑल्सो शो नेगेटिव वैल्यू. Chromium plus 2 to chromium, they also having negative value. And vanadium plus 2 to vanadium, they also have a negative value. So all these three can displace hydrogen. So the correct answer is 3, right? So the correct answer is 3 only. Next, the metal that show the highest and maximum number of oxidation state. Tell me. It's a very simple question. The metal that show the highest and maximum number of oxidation state. Option B, sir. B बोल रहे हैं मैंगनीज. डन. इट्स अ वेरी सिंपल क्वेश्चन, राइट. कोई बताएगा कितना मैक्सिमम शो कर सकता है? मैक्सिमम कितना शो करेगा? मैक्सिमम ऑक्सीडेशन स्टेट हाउ मच मैक्सिमम? +4 +3 +5 +6 +7. व्हाट? +7. गुड बेटा. नेक्स्ट, the element which show only one oxidation state other than its elemental form. You need to say the element which show only one oxidation state. ऑप्शन डी, स्कैंडियम, राइट. इट्स वेरी सिंपल. क्या शो करता है? +3. स्कैंडियम शो +3 ऑक्सीडेशन स्टेट. तो ओनली स्कैंडियम विच शो ओनली वन ऑक्सीडेशन स्टेट. नाउ द नेक्स्ट क्वेश्चन इज assertion reason type. So given below are the two statement. One is labeled assertion and other is the reason. So assertion is in aqueous solution chromium +2 is reducing while Mn +3 is oxidizing in nature. Is this correct? Reason: extra stability of the half-filled electronic configuration you observe than the incomplete filled electronic configuration. In the right of the above statement, you have to select the correct option. बताओ भाई. In aqueous solution, Cr+2 is reducing while Mn+3 is oxidizing in nature. Is this correct? Yes. Obviously, if we talk about Cr+3, so in aqueous solution, and Mn+3 is oxidizing in nature. Yes. Scandium, yes sir. Okay, अभी check कर रहे हैं बेटा. So if we have chromium plus 2, so we all know chromium plus 2 they having 3d4. So they have a strong tendency to go to 3d3, right? Because 3d3 they are stable, half filled T2G and Eg. They are stable. So they have a strong tendency to oxidize +2 to +3, right? So in aqueous solution, Cr+2 is reducing. तो रिड्यूसिंग इन नेचर, तो रिड्यूसिंग एजेंट का मतलब क्या है? जो ऑक्सीडाइज हो रहा है. तो ये ऑक्सीडाइज हो रहा है मतलब ये रिड्यूस होने का टेंडेंसी रखता है. तो ये रिड्यूसिंग एजेंट हुआ. इज दिस बिल्कुल करेक्ट? Mn+3 देखो, तो Mn+3 जो है वो 3d4 है. तो ये चाहता है मैं एक इलेक्ट्रॉन लूं और मैं Mn+2 में चला जाऊं. मतलब ये रिडक्शन मतलब ऑक्सीडाइजिंग इन नेचर. तो बोथ द असर्शन आर, असर्शन तो दोनों बातें सही है. और रीजन में भी यही बोला है क्योंकि एक्स्ट्रा स्टेबिलिटी हो जाती है हाफ फील्ड पे. सो बोथ असर्शन एंड रीजन आर करेक्ट, राइट. सो ऑप्शन इज बी. सो बी इज द करेक्ट ऑप्शन, राइट. नाउ चूज द करेक्ट ऑप्शन फ्रॉम द फॉलोइंग. Mn2O7 is in a oil at room temperature. V2O4 reacts with an acid to give VO2 plus. CRO is basic oxide. V2O5 does not react with acid. Which of the following is correct? Yes. देखो मैं एक्सप्लेन करता हूँ. Mn2O7 is an oil at room temperature. This is very much correct. तो liquid होता है. V2O4 react with an acid to give VO2 plus. No, it react with to give VO2 plus only. VO2 plus. तो ये तो wrong है. CrO इज बेसिक, बिल्कुल ये भी सही है, बेसिक ऑक्साइड। V2O5 डज नॉट रिएक्ट विद एसिड, ये गलत है, इट इज एम्फोटेरिक। एम्फोटेरिक, और जो एम्फोटेरिक होते हैं वो रिएक्ट करते हैं बोथ एसिड एंड बेस के साथ, तो एसिड बेस दोनों के साथ रिएक्शन करते हैं, तो दैट्स व्हाई दे आर एम्फोटेरिक इन नेचर। गॉट इट? सो ऑप्शन ए एंड सी आर करेक्ट, ए और सी बिल्कुल करेक्ट है। नेक्स्ट आ जाओ। द ऑरेंज कलर ऑफ K2Cr2O7 एंड पर्पल कलर ऑफ KMnO4 इज ड्यू टू, बताओ। K2Cr2O7 एंड KMnO4 का ऑरेंज कलर किससे होगा? DD ट्रांजिशन? नहीं। DD ट्रांजिशन इन K2Cr4, चार्ज ट्रांसफर। तो हमने पढ़ा था ना अभी, याद हो तो, वेनेडियम, क्रोमियम और मैंगनीज, ये कलरफुल कंपाउंड्स बनाते हैं। अनपेयर इलेक्ट्रॉन नहीं होता है उसके बाद भी, तो वाई, तो उसमें हमने पढ़ा था यहाँ पे चार्ज ट्रांसफर का भी फैक्टर आता है। तो ऑक्सीडेशन स्टेट निकाल निकाल के यहाँ पे हम लोगों को थोड़ा सा देखना होता है, ठीक है, कि ऑक्सीडेशन स्टेट क्या आ रहा है। तो दे आर बेसिकली, अगर आप K2Cr2O7 का देखो तो Cr यहाँ पे +6 फॉर्म में है, और अगर Mn का देखो तो Mn यहाँ पे +7 फॉर्म में है। So in +6 and +7 they do not have any unpaired electron, right? So how they are colored? So they are colored due to the charge transfer transition. तो दोनों में चार्ज ट्रांसफर हो रहा है, राइट, ये पढ़ा था हमने। ए ऑप्शन, हरीश, गुड। सो ड्यू टू द चार्ज ट्रांसफर, तो चार्ज ट्रांसफर के चलते ये इस नेचर के होते हैं। डन। और देखो, diamagnetic lanthanoid ion are. So diamagnetic lanthanoid ions are La3 plus C plus 4. So आपको आइडेंटिफाई करना है कि कौन सा इसमें से डायामैग्नेटिक लेंथेनाइड्स होते हैं। सी बोल रहे हैं बच्चे, ओके, लेट मी चेक। नो बेटा, इट्स नॉट सी, बिकॉज La+3 एंड Ce+4 डायामैग्नेटिक, यू नीड टू सेलेक्ट ना। तो जो सी होता है ना, इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन होता है, दैट इज Xe4f1 5d1 6s2। सो C+4 में ये क्या होगा, डायामैग्नेटिक फॉर्म में हो जाएगा, ठीक है। इसके दोनों इलेक्ट्रॉन, दो, एक तीन, एक चार, सभी इलेक्ट्रॉन्स निकल जाएंगे, तो डायामैग्नेटिक हो गया। जबकि La का भी कुछ ऐसा ही होता है, दैट इज Xe4f0 5d1 6s2। तो ये +3 में दो और एक तीन, तो ये +3 में है ना, तो ये +3 और ऊपर वाला +4, तो +3 और +4 में डायमैग्नेटिक होंगे, तो La3 एंड Ce+4। सो ऑप्शन ए इज एब्सोल्युटली करेक्ट, ठीक है। चलो, ये भी क्वेश्चन सेम है इसी की तरह, बताओ जल्दी। वेरी सिंपल क्वेश्चन। गिवन बिलो आर द टू स्टेटमेंट्स, बोला है स्टेटमेंट वन, इन लैंथेनॉइड्स द फॉर्मेशन ऑफ C+4 इज फेवर्ड बाय द नोबल गैस कॉन्फिगरेशन, तो अभी अभी किया था, इट्स अ सिंपल थिंग। Second, C+4 is in a strong oxidant, reverting to the common +3 oxidation state। तो सभी +3 शो करते थे, तो बोथ स्टेटमेंट वन स्टेटमेंट टू आर ट्रू। तो दोनों के दोनों स्टेटमेंट्स जो हैं +1 और +2 के, वो ट्रू हैं। सो आई होप दिस इज क्लियर। हम्म। नेक्स्ट, गिवन बिलो आर द टू स्टेटमेंट, वन इज लेबल एज असर्शन, अनदर इज रीजन। असर्शन देखो, 5f electrons can participate in bonding to a far greater extent than 4f electron. Is this correct? And reason is 5f orbital are not as buried as 4f orbital. Tell me the correct reason for this, everyone. Yes, everyone. 5f electron can participate in bonding to a far greater extent than 4f electron. This is correct, right? Because जो actinides होते हैं ना, element in which the 5f orbital are being filled, the 5f electron can participate in bonding, right? So the contrast with the lanthanoid element in 4f orbital are being filled, where the 4f electrons largely do not participate in bonding. तो ये statement और reason दोनों का दोनों बिल्कुल correct दे रखा है. So both the reason statements are correct. So we can say that option A is absolutely correct. Clear है? चलो, so this is all है ना. So we already covered some important topics of DNF and try to solve some questions as well. So only these types of question they are going to ask in your JEE examination. So try to prepare, try to read the chapter once again and try to solve the question much as you can, right? जितना solve कर सकते हो उतना एक बार अच्छे से solve करो. अभी तक कोई भी doubt हो तो you can ask. I'm just launching a quick poll here. उस poll को fill करना है सबको, right? Yes, you can fill the poll.